Okay, let's dive into this. Welcome to this explainer, where we're going to unravel a seriously majestic 4.5 billion-year-old mystery today, how the Saturnian system actually came to be. We're going to look at the giant planet itself, its spectacular rings, and its deeply, deeply enigmatic moons. It's basically a true cosmic detective story, and the clues to solving the whole shebang are written entirely in ice, gas, and gravity. To really ground our investigation, let's establish a baseline. Our magic number here is 4.5 billion. That is exactly how many years ago Saturn itself took shape. Picture it, gravity pulling swirling gas and dust together to create this massive, churning gas giant. Then, about 500 million years later, so roughly 4 billion years ago, it finally settled into its current position in the outer solar system.
But, okay, what kind of planet did all that swirling gas and dust actually create? Well, Saturn is mostly made of hydrogen and helium, literally the two lightest elements in the universe. And this brings us to a physical property that is just, honestly, it's pretty funny. Because its massive volume is packed with such lightweight materials, Saturn is the absolute only planet in our solar system with an average density lower than that of water. Meaning, if you could somehow build a colossal bathtub big enough to hold it, Saturn would literally just float like a giant rubber duck.
So, the planet itself is this ancient buoyant giant. But here is the massive question that continues to keep astronomers up at night. We know Saturn is ancient, but are its rings and moons just as old? Are these incredibly iconic rings and the dozens of satellites orbiting the planet actual ancient relics from the dawn of the solar system? Or are they recent cosmic accidents? Let's pivot our investigation from the macro-level planet down to these micro-mysteries.
Section 1. The Ring Origins Debate.
So, Saturn's rings span a mind-boggling 175,000 miles across, yet they are astoundingly thin, typically only about 30 feet thick. I mean, that's incredibly thin for something so vast. Scientists have argued over how this paper-thin disk got here for decades. Two leading frameworks have emerged. First, there's Lami's theory, proposing a totally catastrophic collisional scenario. This suggests the rings formed from the violent fragmentation of a progenitor body. Essentially, an early moon got absolutely shattered to pieces. On the flip side, we have Canop's theory. This model suggests the rings are the shredded remains of a lost Titan-sized moon that migrated inward. As it wandered just a little too close to Saturn's Roche limit, the planet's immense gravity gradually stripped away its icy outer layers, naturally generating the massive inner rings we marvel at today.
Section 2. Enceladus, an origin mystery.
Now, what's really interesting about this setup is Enceladus. It's tiny, only about 313 miles wide, but its origin story completely revolutionizes how we understand the solar system. Consider the first two potential scenarios. Did Enceladus form way back in the primordial subnebula, basically snowballing from a homogeneous mixture of rock and cometary ice right alongside Saturn 4.5 billion years ago? Or, on the other hand, did it form from the mixed debris of an older, completely destroyed generation of moons? If it's the latter, Enceladus might be a sort of recycled moon, made of rock and ice that had already been extensively mixed and processed.
But hold on, because there's a third, highly controversial scenario. Enceladus might actually be a staggeringly young moon. Some of the latest dynamical models suggest it could be only tens to maybe hundreds of millions of years old. In this model, it was born late from the spreading material and cometary pollution of Saturn's current rings. To put that into perspective, in cosmic terms, that would make Enceladus an absolute toddler, born long after the dinosaurs first started roaming the Earth. No way, right?
So, why does all this matter? The absolutely crucial point is how much these origin theories dictate what is actually going on inside the moon. Let's walk through how this breaks down. Whether Enceladus is primordial, formed from old debris, or is a super late arrival, drastically changes our understanding of its initial chemistry. But more importantly, it dictates the possible age of its hidden subsurface ocean. Think about it. An ancient moon might have an ocean that's been reacting with its rocky core for billions of years, giving it a long, super stable environment. But a staggeringly young moon, that means the ocean is a totally recent phenomenon. The timing, the extent, and the starting material of these water-rock interactions, they ultimately control the moon's potential for habitability. It's the whole ballgame.
Section 3. A constantly evolving system.
Saturn and its companions are definitely not static museum pieces gathering dust. To see this active evolution, we just need to look at Enceladus today. The Cassini mission completely upended our expectations when it discovered over 100 separate jets erupting from surface fissures at the moon's south pole. These fissures are known as tiger stripes, and finding them,
It proved beyond a shadow of a doubt that Enceladus has a global subsurface ocean, complete with active hydrothermal vents interacting directly with a rocky core. And this brilliantly illustrates the connectivity of the entire Saturnian system. Let's look at the actual steps happening right now out there in space. Step 1. Hydrothermal vents at the ocean floor heat the water, creating this complex, bubbling chemical soup. Step 2. All that pressure causes massive jets of water vapor and ice grains to literally erupt through those tiger stripe fissures straight into space. And step 3, okay, this is the really amazing part. A significant chunk of those escaping ice grains actually break free of the moon's gravity, get trapped in Saturn's orbit, and actively build and sustain Saturn's outermost E-ring. The moon is literally painting a ring around its parent planet as we speak. How cool is that?
Now, let's zoom over to another area of the rings to see how this dynamic behavior builds even more complexity. Take the F-ring, for example. It sits delicately near Saturn's Roche limit and is constantly being reshaped by two tiny shepherd moons named Prometheus and Pandora. These two moons act like a dual-frequency forcing mechanism. Prometheus dips in and carves channels which triggers these dense knots of material, while Pandora kind of modulates the outer edge to keep things contained. Their gravitational dance continuously creates these crazy quasi-periodic patterns, clumps, and streamers. They are quite literally reshaping the ring before our very eyes in a deterministic, endless cycle of clumping and dispersal.
So what does this all mean? What's the big takeaway here? As this quote so aptly summarizes, Saturn concentrates a remarkable diversity of physical processes in a single system. By studying Saturn's incredibly violent, shifting history, the outgassing of its moons, and its granular disk dynamics, we aren't just learning about one single planet. We are using it as this massive, natural laboratory to refine our theories of planetary formation, disk accretion, and resonance across the entire universe.
Which leaves us with a pretty profound question to ponder as we wrap up this explainer. Think about the majestic rings, those icy plumes of Enceladus, the chaotic, intricate dance of the shepherd moons. Is what we see of Saturn today simply a fleeting snapshot of a deeply dynamic, ever-shifting cosmic system? If we had looked a billion years ago, or, if we look a billion years from now, would this system even be recognizable? It's a wonderful reminder of the ever-changing nature of the cosmos. Thanks for diving into this with me today, and keep questioning the universe around you.